let us continue further with our new topic, that is for the numerical integration. Now we shall discuss about some differential equations of linear or single order. Linear differential equation of single degree or single order. Then we have the main two methods in this for solving that, and both are the important from exam point of view, and functioning of the both is somehow similar, but the formulas are different for the both. Objective is same, rather objective is same, but the procedure is different. Now we start with solution of linear differential equation, or we sometimes call it IVP. IVP means initial value problem, because in these problems the initial conditions are almost given. If they are not given, we cannot solve them completely. Let us discuss it with an example. Let us see first method, that is Euler's method. For solving the IVP, IVP means initial value problem. Or the differential equations of linear differential equation. Simply we call linear differential equations. First we see the procedure for the Euler's method. Euler's method is simple one, that is y I plus 1 is equal to yi plus h times f of xi and yi, where I varies from 0, 1, 2, 3 and so on. It is the standard result for the Euler's method to solve the linear differential equation. Now we will discuss about the each parameter who are y, h, xi and yi. Let us take an example. Say solve the IVP. Solve the IVP, that dy by dx is equal to y minus x given y1 is equal to 5 with h is equal to 0.1. It is the first formation of the problem. Next we see how it can be changed. It is the main problem. It is a linear equation dy by dx is equal to y minus x. The only difference which can create here, the function may be x into y square minus x, y plus x upon y minus x in the two variables. Simple function in two variables. And these values here we call them initial value. Due to this problem is also called the initial value problem. With the help of these initial values, we can completely solve this differential equation or the linear differential equation. And height, what does it mean? By taking height is equal to 0.1. Sometimes it is directly given, sometimes it is hidden. That we see in the further topics how we calculate for the h. Now it is a simple and the straightforward formation, and the same formation we will get in the other methods also. As I said, the objective is same to solve them. Now from solution we always start here. This value with y, it is called x0. x0 is equal to 1 and x1 is equal to 5. x0 is equal to 1 and y0 is equal to 5. It is y and it is x. You can start with x1, y1, and here I have taken the values from 0 to 1 to 3. You can take it for 1, 2, 3 and so on. There is no difference. Here x0 is equal to 1, y0 is equal to 5 and h is equal to 0.1 and function is y minus x. These are our primary requirements 1, 2 and 3 to solve any linear differential equation. It is always clear, only sometime the problem is created here, it is hidden. When it is hidden, we shall see how to find it out. Now we start solving this problem, the given problem here. These are the initial values provided to us and we note the formula yi plus 1 is equal to yi plus h times f of xi and yi. Let us take its number 1 and we start our calculations. Put I is equal to 0 as we have taken the variation from 0 to so on. If we put I is equal to 0 in 1, we get y1 is equal to y0 plus h times f of x0 comma y0. Here what is y0? y0 is 5 plus what is h? h is 0.1 f of x0 y0, f of 1 comma 5. It means next step what we have to do, it is 5 plus 0.1 into, it is 1 comma 5. Here is the function y minus x. We have to put these values into this function. These values into the function. This function is in two variables x and y. It has also two values x and y. If we put here y is equal to 5 and x is equal to minus 1. Whatever may be the formation of the algebra, it may be y plus x upon y minus x, y minus x square, y plus 2x, and that may be the simple differences. Otherwise the procedure is same. That is equal to 5 plus 0.1 into 4 and that is equal to 5.4. It is y1. That is the end of the first step. Now for the second step, here we get y1 is equal to 5.4 and from where x1 comes. Now x1 comes from the given values. Here it is x0. x0 is 1. That is equal to 1 plus height of the interval, that is 0.1. Next value is 1.1. For the next step, it will be 1.2. For the next step, it will be 1.3. We always start with the given value of the x. If it is 0, we will start from 0 plus height. Now, in the same manner as we did here, we can repeat this step again. That is, put I is equal to 1 in 1. Now if we put I here, we get y2 is equal to y1 plus h times f of x1 comma y1. It means y2 is equal to, what is y1? That is 5.4 plus h 0.1 into f of x1 y1. x1 is 1.1 comma 5.4. That is y2 is equal to 5.4 plus 0.1 and again we put these values in the function, that is 5.4 minus 1.1 and that's equal to 5.4 plus 0.1 into 3.3, that is equal to 5.4 plus 0.3 5.33, that is equal to 5.73. It is y2. Again we can proceed with the values. The y2 is equal to 5.73, and what's about x2? That is equal to, here it is 1.1 plus 0.1, that is equal to 1.2. And we can repeat this step again and again the same procedure until we get the repetition of the values or the approximately equal values. But the three steps are the sufficient for the exams purpose of view. Only 1, 2 and one more step is sufficient. That remember, always the algebraic function may be the difference, but here we will get only algebraic functions, not any transcendental function. It may be exponential sometimes, but maximum it may be. Okay, you are right. It is 4.3 and it is 0.43 and it is 5.83. That is the procedure for Euler's method. We can solve any problem in this way. Now let's see the further method, and by changing the formation of the problem, that is